All right, good morning, everybody. Welcome back for day 2 of the Heads and Chairs meeting. I'm Kevin Gobert from Valparaiso University, was one of the organizing members of this year's meeting, along with Rich Wagner. And as he stated yesterday, he wasn't going to be able to be here today, so I will be your guide throughout the morning. So today's 2 primary sessions are focusing on data, technology, and just all of this stuff that we do all the time and is rapidly changing. And so we have a couple of speakers this morning and plenty of time for discussion to talk about the issues and challenges and opportunities that we're facing in our big data world of meteorology. And so first this morning, we have Mohan Ramamurthy from Unidata to give us a perspective on data storage and access and all the wonderful things that Unidata is doing to help us do our jobs better. Mohan.
Thank you, Kevin, and thank you to the organizers for the kind invitation to come and talk to you all about big data opportunities, challenges for academia in general, and Unidata in particular, so that we can serve you all better going forward. My sympathies to those of you who have been in this building for 5 continuous days. It's been a long week for some of you, I know, so I'll try to keep this talk as engaging and exciting as possible. I'm Mohan Ramamurthy. I'm director of Unidata, and I come from one of the institutions that you all have been affiliated with, and that's University of Illinois in Urbana-Champaign. I spent almost 17 years on the faculty, so I know what you all go through in your daily drill with regard to your teaching responsibilities, research, and service to your community. And I used to be a very active user of many of the tools and services that Unidata and NCAR have provided over the years. I'm going to give you a quick overview of Unidata before shifting gear to focusing on big data. Unidata was established in 1984, and Unidata came out of a community conversation that took place beginning in 1982-83. There was a seminal workshop that was hosted by Warren Suomi and Don Johnson at Madison, Wisconsin in May 1983, where Unidata was essentially conceived. And I know of at least one person in this room who was at that meeting in 1983, and that's you, Fred. There are a few others, so my apologies. I didn't get a full list of the attendees at that meeting. And then subsequently, that group came to the UCAR members meeting, passed a resolution to asking UCAR to take the lead in establishing a national facility for universities, because the teletypes were getting dismantled at universities because the Weather Service was no longer going to provide real-time weather information to universities using teletypes. And the Weather Service switched to a proprietary technology called AFOS. The old-timers may remember what AFOS was. And it essentially took a whole room full of hardware and terminals, and that was essentially proprietary, and universities were shut out of access to real-time meteorological data. So Unidata was conceived. At that time, Unidata was called University Data Project. And the proposal to create Unidata was actually written by John Dutton, the then chair of the Board of Trustees, and submitted through UCAR. And as they say, the rest is history, because NSF actually funded that proposal to establish Unidata. So we are extremely thankful to the community and NSF for establishing Unidata. It's one of the, much like how UCAR and NCAR came about. There was nobody in UCAR and NCAR creating the institution, and the same thing happened with the Unidata as well. And here is a list of our core activities. Our bread and butter is acquiring and distributing and providing access to real-time meteorological data. roughly 1 terabyte of data gets downloaded or accessed from Unidata every single day, 365 days. Providing data is not sufficient because people need tools to process, manage, analyze, and visualize data. So Unidata develops a suite of software for doing all those things. And we also provide training and education and support to our users. That is a significant responsibility for the program center because the community needs help in using our data services and tools. We also broker and negotiate data and software agreements. Unidata does not create any of the data we provide to the community. All of it comes from some other source. So we actually interface on behalf of you all, work with the National Weather Service, weather services in other countries, other parts of NOAA, such as Israel, to bring data and sometimes even commercial vendors. We have 2 commercial proprietary data sets that flow to your universities, namely Lightning data, that in the US is in the hands of the private sector, and ACARS, the commercial aircraft instrumented observations, which again is in the private sector. And in addition to all this, as part of our responsibilities, we also work to develop and advance standards and conventions for atmospheric and geoscience data, metadata standards, as well as data standards. And probably if I ask for a raise of hands, every hand will go up because NetCDF is one of those data formats that is widely used in the geoscience community and has become a de facto standard for the geosciences that came out of Unidata. Our niche and mission include providing data services that I just described to advance Earth system science research and education, and that should please Tony because his vision calls for Earth system science research and prediction as one of the vision for UCAR going forward. And a few years ago, as we developed our strategic plan, we engaged in a discussion about data friction and reducing the barrier to using data quickly, effectively, efficiently by researchers. By many accounts, researchers, postdoc students spend over 80% of their time processing, managing, before they actually get to doing the analysis and interpretation and arriving at their results. And we wanted to shrink that time to research and flip that ratio from 80-20 to 20-80. At least that was our vision. I can't tell you whether we have actually accomplished that, but we are working toward that goal. Here is a very busy slide, my apologies, but this is, a one-slide version of the bullets I showed you a couple of slides ago in terms of areas of emphasis or focus in the Unidata program. We actually provide data through over 30 different data streams. Everything from surface, upper air observations, radar, satellite, lightning, model output, you name it. We actually acquire and distribute to the community. Everything happens in real time with latencies of a few milliseconds. So if a radar takes observation at some location, that radar observation is transmitted and made available to you all within a matter of seconds. And all of the National Weather Service radar locations, as well as FAA and DoD radar locations, are instrumented with one of Unidata's data acquisition and distribution systems. And that became part of the national information infrastructure about a dozen years ago. We have both push and pull technologies. By that I mean we actually have very much like, Associated Press or Reuters bulletin type approach to moving data as the data information becomes available to the recipients, as well as we have data servers hosting the data. And if you don't want to subscribe to the particular data stream, then you can actually pull the data as and when you need from any location, any device via the internet. We have software, lots of acronyms there, my apologies again, but it just shows the breadth of software tools we develop or we support within the Unidata program. Not all of the software listed there are created by Unidata, and you will see that there is Genpact, Mercatus, and AWIPS2. All three of these software originate elsewhere, like Mercatus from Wisconsin, Genpact from NSAP, and AWIPS from National Weather Service, which we take from them, and that's the negotiation and brokering I mentioned to you earlier on behalf of the community, and we essentially repackage them for use by you all, because you all don't have the same kind of consoles and computers that a typical weather service forecast office has or a national center has. And so we have to work to reduce the footprint of those software so that they are usable in universities. I've already mentioned to you that we also do support and training. Each year we have training workshops, and if you walk to the Unidata Program Center now, you will see an array of nearly 20 computers lined up because we are starting software training workshops on Monday for about 2.5, 3 weeks. So we actually invite the community to come to these training workshops and do hands-on training for roughly 2.5 weeks on Unidata packages, and it's all free. The only thing you pay for is coffee and cookies. We also do regional workshops. Some of you have hosted these regional workshops. Oklahoma hosted one about 8-10 years ago, one of these regional workshops, and a few other institutions here have also hosted such workshops. And just a couple of months ago, we went to University of Wisconsin to do training for SSCC and the Department of Atmospheric and Oceanic Sciences on Python. In addition to all these things, Unidata is probably one of the few programs in this institution that gives out money. Every year we give out $100,000 to universities so that universities can take greater advantage of Unidata's offerings, whether it's data or software or our systems. And since I took over the program, we have given away roughly $1.2 million to 83 institutions. And that program resided at NSF before Unidata took over in 2003. Here is a kind of a overview diagram of this push system I described to you. The beauty of the push system is that any IP address, any node on the internet can be an ingest point for any kind of data. So radar data, I told you, comes from all of the Weather Service, DoD, and FAA radar locations. Model output can come from NSAP or the Canadian Met Center or NOGAPS model from the Navy and European Center and other locations. Satellite data can come from UCAR, where we have ground station, or it can come from SSCC in Wisconsin. And, and similarly, all other 27 data streams originate in some location and data can be ingested 24/7 into the system, and anybody can subscribe to the data and get the piece of data they are interested in. So if you happen to be at Penn State, you may be interested in only radar data from Pennsylvania and neighboring states. You may not care much about radar data from Southern California, and that kind of a flexibility exists in exactly what data streams and what portions of that data stream you want to receive. We essentially push this data to over 700 computers worldwide. And we are one of the biggest users of Internet 2, which is the research network that powers the network at over 300 academic institutions. We push roughly 36 terabytes of data every week, and the number fluctuates depending on how much weather is happening. So if you have lots of radar echoes that are deep, the radar data volume will go up that particular day or that particular hour, and so the rates fluctuate. And we are one of the biggest users, as the last point said on the previous slide. We also have servers here from where you can receive the data if you don't want to manage a 24/7 data reception system. So you can essentially fire up your workstation or laptop or your desktop and point to servers here and do the visualization or analysis where the data resides remotely, but the tool actually does allow for remote visualization, and we have all these different ways the community can access data. And over 800 gigabytes of data get downloaded through that mechanism, in addition to the 1 terabyte I mentioned through the push system. Here is a montage of some of the visualization capabilities and tools that Unidata provides that allow you to visualize all these kinds of data. Now I'm going to shift gear to talk about big data, because big data has been big news for the past 5+ years. One of the person who actually brought attention to this big data challenges for the first time in the community is the gentleman in the third image at the top, Jim Gray. I don't know if you know that individual, but he was a researcher at Microsoft Research. And as he was sailing the Pacific, he disappeared, and there has been no trace of him since. But he coined this and led the writing of this volume that is titled The Fourth Paradigm. He essentially said data has become the fourth paradigm in addition to the 3 traditional ones: theory, experimentation, and simulation or modeling. And that is so indeed true. And since then, numerous scientific publications and technology publications have brought attention to this, including Science and Nature and other ones. National Academy has written several reports. The National Science Board has written several reports on this very important topic, because data has essentially become the lifeblood of science. This has become so big that about 4 years ago, the then associate director of the Directorate for Advanced Cyber Infrastructure at NSF, Ed Seidel, essentially said, is the scientific method dying where the focus is all on data? Because, and he was pointing to, it was meant to be very provocative, Google as an example. There is actually very little theory that, written for Google searches. It is modeled based on data, not based on some other hypothesis. And it can be true in other disciplines if you just blanket with data and observations everywhere, then you can essentially model over the data and create your own model. To some extent, that's what we do with data simulation, but you have clearly theory also going into those data assimilation dynamical equations. In terms of data in our world, in the geosciences, I show you only 4 examples or 4 different types of data. GOES-R, which was supposed to go up on November 4th, less than about 3 weeks from now. Unfortunately, it may be delayed by a few days because of Hurricane Matthew, but it's still expected to go up very soon. And the data rates there are enormous, so that you cannot push the data in real time very easily to a lot of locations. JPSS, who knows when it is going to actually happen? The time lines have slipped many, many times, but the data rates are anticipated to be roughly 3 terabytes from just that particular satellite alone. People in Norman are working on this next generation phased array radar technology, which is again going to lead to enormous increases in data volumes for radar data when you can do a full volume scan in just a matter of a few minutes rather than roughly 20 minutes. And then you have many groups, including NCAR, working on next generation global prediction systems and climate prediction systems that are ensemble-based as well as coupled across various Earth system science domains. And when you do that, again, the volume of data that will be generated is going to skyrocket. And here is a diagram that comes from NCEI, NOAA's archival centers, where they are expecting a huge increase in the data volumes coming from all the different sources that from which they acquire data on an ongoing basis. And you can see some even delta-sized jumps here as they go to the next generation prediction systems. And these numbers are phenomenal. This is petabyte, is the y-axis here. So by 2030, it would be roughly of the order of 160 or 150 petabytes of data being hosted by NCEI. Which brings me to this topic of cloud computing, because cloud computing and big data go hand in hand. Cloud computing is now in its roughly 10th year in an operational sense, because that's when Amazon unveiled its Amazon Web Services. In this short period of 10 years, the uptake of that particular technology and how the worldwide community across all the different sectors take advantage of that approach is phenomenal. Not just hundreds or thousands, but millions of businesses now host their business operations in the cloud. Thousands of government organizations, thousands of school districts, thousands of research labs all over the world are now taking advantage of the cloud. What is so different about the cloud compared to supercomputers that have been around for 50 years in scientific settings and in the defense world? There are some key differences. The cloud provides elasticity. By that, I mean when the demand goes up, you can deploy, hundreds of machines or instances or processors. When the demand goes away, you can shrink that footprint of operations. Give you a couple of examples. You all have your classrooms and labs. The labs meet maybe once or twice a week for a couple of hours. When the lab is in session, you have 50 students wanting to access the same data on the tool for 2 hours. You can fire up these instances just before the lab and shut down those instances after your lab. So you're not paying for your machine and operations 24/7. So it's based on demand, based on your need. That is the elasticity. Another example, when Hurricane Matthew was barreling down the East Coast, everybody wants to access the data and look at the information. But once that has passed, the interest wanes. And so you don't, if you are NOAA, if you are an operation providing that satellite, radar, and other observations, you don't need the same kind of infrastructure and capacity after that event. And these can be fired up and shut down in a matter of minutes. You're not talking about days and months that it takes to set up a computer. These are all essentially virtual computers that are set up in a matter of minutes by a user. So you can do things on demand in terms of taking advantage, and that's the virtualization aspect, because these are all virtual computers for you. There are real computers operated by Amazon or Microsoft or Google, but from your perspective, these are virtual computers that you can access. And you can get any flavor of an operating system. If you are a Linux person, if you're a Red Hat person, you're a CentOS person or a Windows person, you can get those virtual instances in a matter of minutes. And you can run many kinds of data services running in the cloud. And almost all of your smartphones and tablets are accessing information from the cloud. So the resources are available anytime, from any device, from any place. And that's one of the beauties, whereas you cannot do supercomputing and use those resources in the same manner. Why? And Unidata 3 years ago, as part of its strategic plan for the future, moved toward embracing cloud as a platform or as an environment for transitioning to its operations to that particular environment. Why? By the time we had a discussion within this program center and with our community, cloud computing had become much more mature. So you could rely on services coming from cloud vendors. I keep hearing from many of our governing committee members the infrastructure support at their universities is going away for a number of reasons. State budgets are shrinking or flat, so where a department would cut personnel, they're not going to cut faculty, so they cut support staff that are operating these systems. Security has become a huge issue on campuses and everywhere else. So campuses are reining in and asking services to be centralized rather than each department have its own computer labs and clusters and whatnot because of security concerns and power concerns and space usage concerns. I already talked to you about the era of big data that's upon us, and Site CMIP5 activity that has produced many petabytes of data that, cannot be moved around very easily. Also, the new generation of students and the new campus IT environment is such that many universities and colleges are encouraging students to bring their own devices rather than providing them devices in a settings. So students are very comfortable using their tablets, smartphones, and don't want to be tied to workstations necessarily and that kind of environment. And this increasing student expectation on the use of, I remember, I'm dating myself here, you go to a room with a terminal access to an IBM mainframe and type, commands that nobody in the average world can understand to make things happen. Today, you don't have to do that because it's all point and click with your finger, or they are even moving to voice recognition, right, through Siri, Alexa, and Cortana and other systems, where you can say, give me the 500 millibar map at 48 hours from the global forecast system, and we should be able to pull that up, rather than the magic that we did with terminal access. When we surveyed our community, more than half of the respondents said that there is a push within their institution to use more cloud computing resources on their campus. I have already spoken to some of these points, so I'm going to move through quickly and go to the third bullet, which to me is one of the most crucial messages I want to get across to all of you. In this era of big data, we need to be thinking about moving our computing, analysis, processing, and visualization to be very close to the data. That's what I mean by data proximate computing and analysis, or data proximate analytics, rather than in the old era where we actually move data to your local computers, workstations, and clusters. To do that, we have to have an ecosystem in the cloud that is data proximate, where you have analysis tools, you have processing tools, you have visualization tools, all available in that environment to the users. And that is the kind of vision we are working towards at Unidata. I'm going to give you an example of an environment, and you will hear more about this in the upcoming weeks and months. I'm organizing a workshop in partnership with the people in the community and people in NCAR on modeling research in the cloud, where we do essentially end-to-end modeling in the cloud, where you have a WRF or a CESM or MPAS model residing in a cloud setting, all of the data necessary to initialize all of the data simulations procedures and tools are available. You run the model, you do the verification in that environment, you do your analytics, you do your visualization, and publish your results in the cloud that can be accessed by the researchers and students on the other side. We are not there yet, it's just a vision, but that's the kind of environment and playground and ecosystem I'm talking about, having everything in one place. Again, taking advantage of the elasticity and virtualization. Within the program, we have several ongoing activities as we work toward that vision. We have moved some of our product generation already in the cloud, and rather than doing them in data centers and computers here at UCAR, we are moving our desktop tools to work in the cloud so that they can be invoked or accessed through a browser, and you don't have to install that tool on your machine, but you point to a server and that tool essentially appears to you very much like a desktop tool. Why we want to move in that direction? You don't have to then keep up with all the new releases. And it's not just the release. The Integrated Data Viewer, or IDV, is a tool that has dependencies on Java libraries, OpenGL libraries, and other dependencies. And you don't have to keep track of all those updated libraries and install the application every time Unidata has a new release. You basically go to the browser, use the browser to go to the server application and invoke it. And so maintenance on your side goes down significantly. You'll see a slide coming up. We are hosting data servers for AWIPS so that people don't have to operate an AWIPS data ingest system. We are doing the ingest and have the data servers that are ready to be accessed by AWIPS clients so that you don't have to install the AWIPS server suite. We are also working quite a bit with Python tools and Python libraries, because Python has become one of the most significant programming languages and environments for the sciences. To just underscore how important it has become, a few months ago you all saw the news in the press. It made, news everywhere worldwide, and it is on target to receive a Nobel Prize in the next year or two, and that is the gravitational wave observation. That entire work was done using Python in an online setting, rather than use other scientific programming languages or tools. And Unidata is trying to create a platform for hosting Python in a cloud and provide what is called Python notebooks. It's essentially scripting language on the web through a browser. So as you are typing your script, you can see what that script is going to do in real time in terms of analytics or in terms of visualization, in terms of plotting, and in terms of your displays. And that is the Jupyter Hub technology that Unidata is working on. And we are also working with the community to create Python libraries for doing a lot of analysis and visualization in atmospheric sciences using Python. And the last bullet there, we are converting a lot of our applications to run in the cloud and create virtual images of those cloud of our packages so that you don't have to compile, you don't have to configure. Everything is shrink wrapped as a virtual application that you basically have to run, so that you are not trying to figure out, oh, what compiler flags I should turn on. This is all done for you. And the approach, there is a technology called Docker that is allowing us to do that. And we are working to convert our applications to that Docker container environment. We are currently, in terms of resources, leveraging resources from Amazon, Microsoft Azure, Open Commons Consortium, and the NSF Exceed. So we are essentially getting grants from all these organizations to operate our services. Here is an example of how we are leveraging Amazon Elastic Cloud and Amazon Web Services for providing AWIPS servers and other kinds of remote access data servers. Again, the advantage is the scalability, that leverages elasticity that I talked about a short while ago. Here is an example of how we are hosting AWIPS data servers in the in the Microsoft Azure cloud. And in a short period of less than a year, 44 universities have taken advantage of this remote server for AWIPS 2 data servers. And they are essentially installing clients that point to, so we worry about bringing data to that server, processing the data, and making it available. University essentially has to fire up its Cave client and point to the cloud instance that Unidata operates. And a few months ago, one of the universities actually had a lab where the entire lab was using AWIPS, and we saw immediately a spike where the number of access from that institution went from 1 to 22 in a matter of minutes, and they didn't have to worry about having those resources because it was available. And then 2 hours later, the lab ended, and that again is the elasticity I was speaking to you earlier about. And these are the universities that are actually using the remote cloud instance. I talked to you about Docker technology that has dramatically transformed how applications are developed and deployed in the cloud. And there are some benefits that are listed on the right. Small footprint, rapid and lightweight deployment, portability. The nice thing about Docker technology is that you can take that virtual image and run it anywhere you want, because it actually has a mini operating system in the container itself. So you don't have to even have that particular operating system running at your institution. It is in the Docker container itself, and so that increases reuse. Here is just an additional bullet on some of the applications we have containerized that are listed on this particular. And we are not only deploying these applications in our own cloud instances, but we now have a Git library, location where community, you all can download this Docker containers and use them in the cloud resource you have access to. Here is the example of the cloud integrated data viewer tool I mentioned. This IDV tool is a desktop tool, but if you noticed, here there is a URL where you can point to and essentially get access to the tool and visualize the data as shown on this particular slide. And you didn't even have to, all you needed is a browser, which everybody has access to in their tablets or in their. Previously, you couldn't run the IDV in a tablet setting because it had it's 100% Java, and most tablets don't support Java. iOS from Apple does not, it shuts out Java completely. Whereas now if you have an iOS tablet, like an iPad, you can point to this location and run the Cloud IDV from your tablet. I mentioned to you this Jupyter platform, and Unidata is working to connect this Jupyter platform to data servers. So one of the data servers that Unidata has developed is called the Threads data server. So we are connecting this Jupyter Python platform to the Threads data server to pull data, and this Jupyter platform resides in the cloud, and so does the data. This is the data proximate analysis and visualization I was telling you about. And all of the libraries for Python, atmospheric science, meteorology, and scientific analysis are connected to this Jupyter platform, such as MetPy, CartoPy, and a few other Python libraries that allow you to do this. It will also support R, which has now become one of the biggest open source statistical packages, supplanting SAS and SPSS and other proprietary software packages. Here are some examples of what can be done using the current capabilities. You can plot satellite images, look at model output, do time series analysis. All these data sets Unidata actually hosts in a thread server, and they are made available through this Jupyter platform. We are also collaborating with NOAA and the commercial vendors on the NOAA Big Data project, and we worked very closely with Amazon over the last year or so to make this project a success for both NOAA as well as Amazon by moving radar data to the Amazon storage systems so that the community can take advantage of this as part of this NOAA Big Data project. This project has been enormously successful. In a few short months, the amount of radar data accessed from Asheville NCEI has gone down by 80% in just less than 6 months. So vast majority of data now gets accessed from Amazon. And another important success story is that for the first time, the science community has access to archived NextRad data going back to 1994 all the way to 5 minutes ago. We have this seamless access, whereas in the past, when you went to Asheville, then NCDC or NCEI, you could not get both archive and real-time data at the same time. Not only that, to get archive data from, say, 1998 from St. Louis, it would have taken you days, if not weeks, for NCEI to process and provide the data to you. Now it takes minutes to get the data from Amazon. And we have hosted a lot of our tools co-resident with this historical and real-time data archive in Amazon, so that people can do radar analysis in the cloud in real time using all of the data that's hosted there. Now I'm going to shift gear completely to another topic, which is also extremely important for all of you. Because you all know about these mandates that have come from the White House over the last 3-4 years after ClimateGate and all the other things in this era of open science and open data, mandating all of the PIs from NSF, NOAA, NASA. If you get a grant from a federal agency, you now have a mandate to share the data that you produce as part of your research or you use as part of your publication with the rest of the world. Not just a manuscript, but actual data. And agencies, particularly NSF, has been struggling with how to implement that mandate and make it a requirement because NSF has not provided any solutions for hosting the data. They have only come up with solutions for hosting the manuscript, the publication that you have. And Unidata has been working on something called Data Management Resource Center to help PIs to deal with this requirement in terms of how you can host your data from your research using Unidata technologies and tools. We give you a template, we give you help on how you write your data management plan into your proposal, but even more importantly, if the proposal is funded, help you to actually implement that plan with tools and capabilities. And here is an area where the community, much like it did back in 1983 when Unidata was created, you all need to be thinking about, how UCAR can step up and do this, because Unidata does not have the storage systems or the capacity to take data from hundreds of institutions and say, we will host the data and steward it for decades. But we are working to create the tools and capabilities that will help somebody. And we have a pilot project, and some of you actually participated in this pilot project. We had 5 universities step up and said we will participate in this pilot effort to see if our data can be shared more broadly using interoperable standards for data publication and data access. Millersville is one of the universities where data from Pecan Field Project, which was taken using Radioson instruments that was not interoperable data format. Unidata people worked with the Millersville team and others at the EOL to convert the data into NetCDF using standards and conventions and facilitate the sharing of data. A few other universities, and each one had a different kind of data in their hands or in their projects. And we have completed this pilot study, and we are thinking about where do we take this next going forward. So here is one of my last slides, if not the last slide. What does this all mean for academia, for you all to think about? And this is my humble opinion. You all need to be thinking about emphasizing the things that are on this slide. Data, computational, and I would even add geospatial literacy to that bullet, which collectively is the topic that is rolled up as data science. Data science is the area, professional area that is in highest demand. Many business publications publish on an ongoing basis what are the hot topics in the world for hiring and salaries. Data science is #1 this year because every organization, every business is thinking about how to mine, leverage the data they have access to. And that's also true for the sciences. Big data analytics, I don't need to emphasize that much more after this talk, but one of the key aspects is machine learning and artificial intelligence. How do you extract information, not just access big data, but extract information in big data? So if you have an ensemble of 100 model runs, it's not humanly possible to go through all of that output. So you need some intelligent way of mining the data and extracting some of the key features, some of the key things in that data. I already talked about Python and R. So the era of Fortran is coming to an end, and it is always going to be limited to high-performance modeling. But in terms of student analysis, research analysis, it's a language of the past. GIS is another area in terms of layering the information that our science produces with demographics and social science data. Matthew and Sandy are poster child examples of the importance of GIS working very closely with the information that our science produces in terms of decision making and mitigating damage and disaster. Contemporary software engineering practices. I did a lot of programming in my previous life. The notion of software engineering never crossed our mind. We just coded, we just wrote programs. Today there are many tools and approaches on how good code, good libraries, good packages ought to be written. And we need to emphasize that for our student. We all wrestle, right? A student comes in, writes code for his project, for his dissertation, leaves after 2-3 years. That code is a mess for the next student to come and take a look at and see what the heck he or she tried to do in that code. And that's what I mean by contemporary software engineering practices that allow the other person to readily adapt, adopt, use that particular software using modern software engineering practices. Data publication and citation. I've already talked about the data management plan mandates and requirements. So you need to be thinking about how you are going to publish your data and how you are going to cite them, how you will get the DOIs for citation of that data. And then we all need to be thinking about this era of open science. And open science also means many of the grand challenges involve very large teams that are distributed across institution, continents, and how we will do the science in a very open manner. That's all I have. Thank you for your attention. I'll be happy to answer questions or go to the discussion that Kevin would like to lead, I guess.
Great, thank you very much, Mohan. So questions for Mohan?
Yeah, so Phil Austin from UBC. So just a couple things. First of all, I think Unidata should be given quite a bit of credit for being on Python early. I think PyNGL came out 7 years ago or something, and so you guys were into Python before it had really tipped. And for us, this is the first time since the 1980s that the computer science department and the science faculty actually agree on a computer programming language. And that is a huge deal because it means our students previously had a semester of Lisp and no floating point, and essentially it was a wash, and then they wind up having to use MATLAB. And so this actually has made a huge difference to us. So I would also say that software carpentry is something that we are following very closely. And it would be very nice if there were more geophysical, atmospheric science-related lessons with that template, because it's pretty biologically oriented. And that just seems like a great framework to actually communicate. And I would also say that I have a third-year remote sensing course on GitHub written in Jupyter Notebooks that anybody can clone and edit. And so if you're interested in seeing a course that actually is conducted with Python, just send me an email. The other thing I would say is that we do still need hardware-accelerated visualization. And one thing I didn't see on those slides was vapor. And I'm hoping that your commitment to sort of LES scale, OpenGL, graphics card graphics actually continues too, because for us, you know, the web-based sort of cloud-based is still, I mean, I don't see any near-term solution for that besides something like Vapor that could actually do high-volume visualization in real time on a local desktop.
Thank you for your comments. I will add, in addition to software carpentry, now there are data carpentry sessions also being given at many institutions, and Unidata has participated in both software carpentry and data carpentry workshops.
Bob Ellingson, Florida State. Mohan, this year I started trying to translate some of my web applications to Python and first to JavaScript and into that. But there are also at Florida State, we're finally offering our computer science course or computational course in Python. Okay, so we're trying to get that going. But of course, faculty are very reluctant to move away. And one of the things I tried to do, and there are some tools to allow you to translate between languages and the like. And of course, they're not in the same manner, okay? But I wonder if you have been working at all, or Unidata will work on any of this to develop those tools to make the translations easier between certain languages that are available that people use, so that you could use Python.
We will definitely look into, and we will continue to have a conversation with people like you, because we want to build up that ecosystem to go beyond some of the, I mean, we are constrained by the limited number of staff that we can. So one of my vision is to create an open source Python development community for the atmospheric and related sciences. And we can provide the governance and the coordination and things so that we can harness the capabilities and expertise that resides in the community at large. So we definitely want to do that. You also raised mentioned an important thing that I should say. While I have given you a very, very positive picture about cloud computing and big data, people ask me, what are some of the challenges that you need to talk about? One is the business model. Who is going to pay for it? Right now, we are writing grants left and right to get resources from Amazon, Microsoft, Exceed, and other places. That's not sustainable. And we can't write the check because cloud computing is a transactional services-based model for its cost and service, as opposed to infrastructure-based a model where you put up the infrastructure, like the NCAR Wyoming Supercomputing Center. You know, it may cost you $80 million, but every user doesn't have to pay for it, or NCAR doesn't have to pay for it because there are more users of it. But in the Amazon world, every time the meter is continuously running as people are doing things and pulling data out. The other one is what you mentioned, the inertia in the system in academia and elsewhere, and people not wanting to give up their workflows very easily to move to a new paradigm for doing science. And that'll take time. You know, it's going to require education, training to actually make it a reality, because I fully understand the challenges of completely going to a different type of environment for doing your science.
Mohan, I just want to say how much I appreciate Unidata's preeminence in leading the way for tools and data services for our community. I just love loved your presentation. Just a short question with regard to mining big data. Do you have players right now who are involved in looking at like intelligent data thinning and phenomenon extraction and stuff like that?
Not at this time. Again, we don't have all of that expertise in-house, so we have to be working, with the community, where some of that expertise resides, My staff are split between background in computer science, atmospheric science, and there are 14 software engineers, and there's only so much I can ask of them in terms of the different areas of emphasis. Historically, the areas that you are emphasizing, they are very important, but they have not been Unidata's area of expertise.
I'm sure I'm not alone in this, but as one of the people who is passive-aggressively referred to on campus as their system administrator, definitely we do owe you guys a huge gratitude to be able to outsource these resources. The issue that I think I have is the ability to set these up on the campuses, or at least being able to make sure that these resources are known on campuses and being able to set them up with our IT staff so that they can link our infrastructure into yours. Do you guys arrange visits for that type of thing? So that instead of your people talking to me who knows just enough to be a danger to himself and others, instead talking to the people who actually know what they're doing, that would be an incredible help. And also, do you guys coordinate with some of the consortia that are out there, like Great Plains Network and that type of thing, Greg Monaco and Internet 2, et cetera?
Not on the last point, Unidata doesn't interface with them, but people in UCAR and NCAR absolutely interface with them. UCAR, NCAR, we have a seat at the table in terms of Internet to community and discussions, and several people from this institution actually do. In terms of interfacing with the IT folks at your institution, we can definitely facilitate that, but we don't have a formal visitors program for hosting visitors of that kind. That doesn't mean they cannot attend our workshops or come and visit the program center, and we would be more than happy to have discussions and conversations with them.
One of the big problems with infrastructure of this type is there's always the networks and things like that, the resources, but there's always, quote, the last mile, as it's always called. And that tends to be a stopping factor for our institution to fully engage, and instead leaving it to us where we have other things to do. So.
All right, great. Thank you very much. We are at our morning break, so we will go ahead and reconvene at 9:45. Our first presentation after the break will be virtual. They will be joining us from somewhere other than this room, so do try to get back right around 9:45 so we can get started and utilize their time well. Thank you all very much. Our way back to our seats so we can continue on with our morning program. All right, so this next session will be on ways in which technology is being used throughout geoscience education and really leveraging some of these technologies we were hearing about from Mohan this morning. And our first presenter is joining us remotely, who is from the AGU and going to enlighten us about this virtual poster showcase that the AGU is doing. I heard about it 2 days ago at the UCAR members meeting. Thought it was a really neat way in which we can engage our students in the research process and getting feedback on some of their work, but through this asynchronous poster presentation mechanism that they've developed there. So we'll go ahead and have Antonia Asher get started remotely for us.
Good morning. Can you hear me?
Yes, we can.
Fantastic. So, thank you for the opportunity to tell you a little bit about the work of the showcase. I am very excited to tell you about how you can be faculty and students in this program. So if I could help you and look at all of you in the little card there, I'm asking for a show of hands. How many people have heard about it? And, you know, it's possible that most people heard about it, but some of you have. But if you haven't, here's a very high level look at what this showcase is all about. It's a digital way for their funds. They can be presenting from anywhere. It is open to undergraduate students and graduate students. It is a very convenient way so that they don't have to travel anywhere. And more importantly, it allows the students to gain some skills other necessary for their success in the workforce. And that does not mean it's a way to increase diversity by providing access and creating opportunities for students and possibly may not have the resources to travel to those students. So before I really delve into what the showcase is all about, I want to share with you a few stories. And these are stories that we've been collecting in the last couple of years. Please bear with me. This is Daniel. Daniel is actually was a senior college student in Southwest Texas. Has never ever presented a proposal, never written an abstract, or even attended a meeting. The professor gives him an opportunity to participate in the virtual poster showcase when we were sort of testing this concept several years ago. And the student did such a great job, he ended up doing the first prize in the showcase. And this moment was transformational for me. This is what he told us. He said that given the confidence and the ability to know that something was authentic, he felt that was given a way to then transfer into a neuromuscular vision. He has since graduated and is now in the workforce. So this was a life-changing event for him. This is Trisha. Trisha is obviously in Hawaii and has had many opportunities to do research, but she has never presented her research outside of her classroom or her thesis. While she was working on the research project, her advisor told her that she was going to be presenting with international research at an international conference. She ended up participating in the virtual poster showcase last year, and used it as a way to sort of dry run her presentation. She got fantastic feedback from her peers and from a professor, and she was able to teach her presentation before she went to the conference. And she, again, did a very good job of presenting her research at that conference. So far more confident than she had been before. This last story is my favorite, however. This is I mean, it's not a great school, but a lot of people are undergraduates, and some of them Morgan. He goes to the professor, this more study, and, we participate in the virtual showcase. And so, when shared by the fact that here are all these students and other faculty who were asking the questions, he really goes in this direction and realized how generous the community was. And he came back the next year, then with another role there, and since then, he went on to graduate, and now he's a graduate student, and has been very about being a judge. So that is why I think that to other students. It's also the whole idea that if you're going to keep it social, you want to do that. So that's a really wonderful thing opportunity now, and as well. And we did really well to make questions for the students. So I share these stories with you. Many of you probably know about the report from the president This was the federal report from a few years ago. And this is how the education forms the content of the report is created is in the model and the model. So how, what kind of things have to happen to meet the president's goals for a That's what we talk about here. We think that every school that does research should have their opportunity to present also. We know that there are 40,000 students that are currently enrolled in state colleges and 40 colleges that are managed by Now, if you like how we do the thought, or also more to do with how
All right, thank you very much. Let's give a round of applause. Are there any questions? I have one. So you said that there are 3 virtual poster sessions a year. Is there any regular timing that you're anticipating for these into the future? Great, thank you. Any other questions about the virtual poster showcase? All right, thank you so much for joining us. It was a great presentation.
Thank you.
Thanks. All right, our next presenter is Sam Ng from Metropolitan State University, just down the road in Denver. He's going to be talking to us about utilizing AWIPS 2 in an undergraduate classroom and telling us about the challenges and opportunities that faced for him. So let's welcome Sam.
Okay. Thank you for having me today. I'm going to talk about how I'm integrating AWIPS 2 into my classroom and into my lectures. So basically, my talk's going to be 4 different parts. I'm talking about the overview of the current lab, and then we'll talk about the early days with AWIPS 2, the challenges and hurdles. There were plenty of them. And then the current situation, which is perfect, and then conclusions, what I can do down the road with AWIPS 2. So currently at Metro State or MSU Denver, our lab consists of 22 Dell Precision desktop, which was just recently upgraded. 20 of the stations have dual monitors, so they can actually, current state, we can put up 2 different CAVE clients. So the student can use 2 different CAVE clients at once. They can also use a CAVE client and an IDV as well. I'll show a little video of that. All of these workstations are running on Red Hat OS, with the exception of one, which is running on Windows. We have a video projector and then 450-inch LCD display in the back showing constant remote sensing data such as radar and satellite. And then one LCD is in the hallway displaying active weather all the time. All of these are capable of displaying AWIPS 2. So the weather's lab software we have the old NTL suite still. Some of the students still likes this software, but I'll talk about this a little bit more later on. Genpack IDV, we have non-Unidata software, sorry Mohan, GR Level, GR Earth, and then AWIPS 2, which is the software of choice for me. So how this got started, the AWIPS 2 project at MSU Denver, was we were awarded a equipment grant in 2014. Myself and my co-PI, Chris Kimmett, we wrote this grant, we got it. We asked for a little bit more money than Unidata was allowed. So what happened was the dean provided additional money for us so we could make our grant possible. We got 25 high-end video cards, which costs about $350 to $400, and then we got a pretty high-end server to service our need for AWIPS 2 in our lab. So here are the specs currently. The EDIC server has 32 gigs of RAM, 2 16-core processors, yada, 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 SSD, 300 gigabyte hard drive. The EDIC server has to be run on a Linux system, where currently the CAVE client, there's 3 different versions of CAVE clients you can use for AWIPS 2, Windows, Mac, and the Red Hat version. I prefer the Red Hat version because that's the most stable. The next would be Windows, which is, we use it, and there's little things that's wrong with it. And probably the least stable one is the Mac version. Early days, compiling AWIPS 2 was fairly simple and painless, but getting the data to show up was the challenging part, being an early adopter. We also had the 300 gigabyte SSD drive to ingest high resolution data as well. Some of the things that weren't working properly was the up air data at first. I think the version 14.xxx did not have the upper air data set. Later version does, and it currently does have the upper air data set plotted for you. Some of the model data sets were not updating properly, and only several cave clients were able to be opened at once before the edX server crashed. So how do we fix these issues? A couple of them through brute force methods. First one, we figure out, thanks to Jeff Weber and Michael James, the Unidata, kudos to them. They've been very helpful during the early days of getting AWIPS 2 up and running, and they actually came down to look at some of our issues. Jeff and Michael came down. Actually, no, Jeff came down, and then Michael through email. The PQAC had to be readjusted to comment out some of the data set that had bad tables, such as the Canadian model and the NavGem. We still have those commented out, so we don't get those data sets. Also, we had to reconfigure some of the files to change the memory size with the request.shell script and the wrapper.config. This was the lines that we switch. We just bumped the memory up, double the memories they were requesting for, and actually we actually tripled it at 1.2. With the new system, you don't have to do that. Because since the Cave client is a Java-based client, they included a subprogram called garbage collection, which cleans out AWIPS 2 little, I guess, programs that's being cached on a regular basis. So that has been a godsend, and you don't have to readjust for those two files anymore when you download it and install it. The latest version of 16 point, I believe, is 1.4. It's the most lab-friendly and the most stable version that I've tested. It has not crashed in several weeks on several of the machines that I have left up. And we're able to open up to 20 Cave clients at once, probably even more. But there's still some challenges. You have to have met the minimum system requirements, which are on their website. 8 gigs of memory is preferred for your desktop or workstation. We have 16, so that's pretty beefy. Again, I guess the law for computing, more RAM, the better your computer will be. 2 gigs video card. Again, the edX server, these are recommendations, and it has to be run on Red Hat or CentOS. Currently, I'm using AWIPS 2 in my classes for map discussion and class lecture. One of the reasons is it's highly customizable. The preset colors intervals are ideal for meteorological use. That's not so with IDV. You have to tinker with it. It's user-friendly to locate meteorological parameters. The graphic and animations are smooth and consistent. When you do a cross-section, it looks great on AWIPS 2. Where in IDV, you can make it look really good, but you have to really tinker with it to make your cross-section look really good. Where AWIPS 2, you just click and drag, and it looks fantastic. Here's two of the displays we have. We have a virtual map wall, and we have a hallway display, and those have been running for several weeks without rebooting. Actually, I rebooted one of the machines yesterday, so I lie. It's been running for like 3 weeks, and one of them I had to reboot. Otherwise, it's been really working really well. In the classroom, AWIPS 2 is best used mainly for nowcasting and forecasting only. So some of the labs I've done, nowcasting lab, are lake effect snow events, maybe do a medium to short range forecast. Mountain wave exercise, cross sections looks great. You have a high resolution model, which is fantastic if you're doing mountain waves. or talking about mountain waves, and then radar and satellite meteorology. My course, I use it for severe weather lab. Most of my labs are very generic, not very specific, like your typical synoptic lab, because one of the drawbacks with AWIPS 2 is we can't really go back and use past data, okay? So here's a lab example I have. Again, very generic. I asked the student to look for certain patterns. So it's more like a Mad Libs lab, but at least they're using it and tinkering with it and playing with it. So again, disadvantages, cannot re-import or import archive data sets yet. I think on the government version, there is the capability, but on the Unidata version, it's not there yet. And I've talked to Michael James about it. I think it's supposed to be, he's playing with it, but again, it's not a deal breaker. IDV still remains the software of choice for courses that requires historical data sets. So, it's great. It's a great software, IDV. If you have the capability, you can use both of them at once, and most of our students do use both of them at once when they are in my classes. An edict server is required for a Cave client to work properly, as Mohan talked about earlier. We have a local Cave client, which is great, very fast, very customizable. The data we don't want, we just comment it out. The data we want, we can actually store it for 7 days. We have enough storage capacity, where I think on the remote server, the Unidata server, they only have it for 1 or 2 days. I'm not sure about that one. So one of the advantages of having a local edict server is you can store the data as long as you want, as long as you have the space for it. Here's an image to show that AWIPS 2 and IDV can play well together at the same time. I can play this. Oh, sorry. Where I know how to use technology. Maybe not. QuickTime not available. Okay, so I didn't embed it correctly, sorry. User error, but as you can see, it was supposed to animate, and on your right-hand side is IDV, and then on your left-hand side is AWIPS 2, and they were both running at the same time, very fast and smooth. And here's an animation to show the capability of AWIPS 2. You can overlay data. I have currently overlay IR image with the NextRad composite, and then overlay on the top of that is the RAP analysis 500 millibar chart. So, and I have, typically this is what I have up on the hallway weather display just for the students to pass by. I've gotten a lot of non-majors that stop me and ask me about the weather. So it's a very good recruiting tool, this AWIPS 2 software. One of the bonus part with AWIPS 2 is it has the software to display what the weather service uses, the D2D perspective. And as you can see here, it's very user-friendly, the menu bar. But also, it also has the National Center perspective, if you look here. So you can also plot the National Center perspective, which is very similar to the NTL, the NMAP2 suite in the NTL software. So if you're still using the NTL software, you don't have to lose that completely with AWIPS 2, which is great. And then conclusion, since the initial download installation of AWIPS 2 at Metro State, the software has improved to a point where you can make real quick and real-time weather analysis. And it's very encouraged in my class for my forecasting lab and other courses, which I do more forecasting and nowcasting for. So the student actually, just from a quick poll I did, the students like AWIPS 2 better than IDV because of the just the graphics and the the capability it has for forecasting. They don't have to tinker with some of the intervals. The intervals are preset and are meteorological friendly. Accessing the archive data is still currently unavailable. Again, as I said, it's not a game breaker. Students tend to like the graphics, as I said before, very highly customizable. And then with the improved stability, AWIPS 2 can be used as a virtual map wall and display, hallway display. So it's great, and it updates by itself currently, so it's a great software. And that's all I have.
All right, questions for Sam? I have one. With all the difficulty with getting the EDX server up and running, would you do it again?
Now, yes, because it's very stable. You know, with it would have been a lot harder if I didn't have a part-time Unix administrator. Chris is, you know, a quarter-time loan to us, and he's been very helpful. Since, you know, at Metro State we teach a 4-4 load, it's kind of hard to do that all by myself, but it's been great. So, yeah.
Great. Any other questions for Sam?
Thanks.
All right, thanks, Sam. All right, our final presentation in this morning's session is with Allison Rockwell and Rich Clark. They will be talking to us about synergistic environments in graduate and undergraduate education using instrumentation and measurements. Excellent.
Good morning. We call it Segway for short. And well, I'm just going to lead off here. I'm Rich Clark and my colleague Allison Rockwell, and Rich Jeffries from the Comet and his designees of some of the instructional designers and graphic designers from Comet are all involved. It's actually a fairly large group. There's a number of subject matter experts involved, and want to thank National Science Foundation for funding Segway, and especially Amanda Adams is in the audience. Thank you. And it's a collaboration between EOL and Comet and the university community. I guess that's through me. Something that I've been really, really excited about for many, many years. I can remember 20 years ago talking to Roger Wakamoto about creating Comet-like modules, MEDED modules for instrumentation. For instrumentation course, to be used as supplements. That's the way we envision them, to be used as supplements in instrumentation, measurement courses, observing systems, and things like that. For those individuals that may not have the opportunity to be out in a field project, taking part in a field project where you can gain that hands-on, authentic experience. We still want our students to have an authentic experience. So we're really quite excited. We're just getting started. We had a meeting the other day with subject matter experts. Our plan is to produce 3 modules per year. I'm going to let Allison talk more about that in a second, but I just want to say we're excited. We hope that you're going to participate as friendly users. We'll be after you as friendly users, and hope that you'll be involved in that. And I'll turn it over to Allison now, who will cover the main body of the proposal, or the project.
Thank you, Rich. Yes, we're very excited to be part of this project to develop a series of online, freely accessible instrumentation and measurements training modules for the user community. Okay, so I'm going to talk a little bit more about the actual nuts and bolts of the project. We received 3 years of funding from the National Science Foundation to produce a total of 9 modules, and the EOL Director's Office has provided funding to do 1 module, the introduction, that we're currently working on. So there's going to be a total of 10 modules in this series. and they're going to be hosted on the Comet MedEd platform, which currently has over 450,000 users. So that's a tremendous resource right there that we can tap into and let them know about these series of modules. Our target audience is upper-level undergraduate students to graduate students and first and second year PhD students. Each module we're targeting to be about 60 to 75 minutes in length for a student or participant to complete the module and go through each step and take the assessments, etc. And the EOL staff are serving as a subject matter expert, so we're leveraging the scientists and the engineers within the lab to help develop the content. Each module starts out with having well-planned learning objectives that we're in the process of developing those right now for each module. And then that's going to help guide the outline and then the subsequent content as we move forward. And as Rich said, these are designed to supplement or augment face-to-face instruction. They're not designed to replace it by any means. So hopefully this will enhance current classroom instruction, but they can also be used as a standalone piece if people are interested in learning about these different, the different topics. We're designing this to engage the students in forward-thinking measurement techniques, so we're not going to spend a lot of time on older formats, so we're really going to be trying to lay out the fundamental principles and look ahead at what are some of the up-and-coming techniques. And each module is going to have videos, graphics, interactive educational tools that Comet has an amazing suite of, and assessments as well. So students can complete these modules and be assessed at the end of the module, and that assessment can then be sent to an instructor. And so that's how it's a really nice way to integrate these into classroom instruction. We have a nice project management workflow that we have designed each module to be developed on. As you can see, there's lots of ways to provide user feedback through each step of each phase of the project. We'll be getting, or the subject matter experts will be getting oversight from Comet staff, from myself, I'm in EOL, and also Rich Clark providing input from representing the university community. So we develop each of these modules, then we'll also be having a review of these through faculty. We have a nice pool of faculty who will be kind of a friendly user community who will be reviewing these and hopefully integrating them into their instrumentation courses. And then we'll release these and publish them. Finally, we're planning on a final release in August of each year, so they'll be available for that following semester. So here's our development cycle. So we're in the depths of getting the first 3 modules developed with the subject matter experts, and we have a clear timeline and milestones set out for them. So we'll be developing the modules for the first 6 to 8 months, then they'll be put into review, and then we'll implement and publish them. And then the year 2 development cycle is that we'll have extended activities at AGU and AMS each year, probably alternating locations and having workshops, poster presentations and/or user sessions where people can get experience and see these modules. Here's the list of delivered modules that we have scoped out for each year. So the current production is the Introduction to Instrumentation and Measurements, and Rich is working on that one. And then the ones that are funded in the Segway proposal, there's 9 of them, are the remaining here, so 3 each year, and we're focusing on variables, so the techniques to measure them and also the instrumentation to measure those variables, with one module on the instrument performance characteristics, since that's such an important topic. And then we have subject matter experts from EOL serving as the lead content developer for each of these, but they'll be able to work with other staff within EOL, so we have a well-founded content developed for each of the topics. And each module will also have a scientific and an engineering spin on them. So we're really trying to bring the two together to show the engineering and science aspect of things. And so our SME team, as we fondly call them, will, as I said, collaborate with a team of other EOL staff to ensure a deep knowledge base. They're going to be developing content, the learning objectives, the content outline, providing ideas on graphics and such. And then the SME team will also review the other people's content and modules along the way too. So it's really truly a group effort here that we're doing. And so I'm going to pass this over to Rich now, and he's going to talk about the assessment and evaluation of these, because we want to make sure that we have a strong feedback loop to make these as strong as possible.
And before I do, I just want to add to what Allison was saying. You know, we're really trying to make this an interactive, authentic, but virtual environment, right? Where you can immerse yourself into the learning exercise. To give you an example, imagine, you know, site selection is a big deal. For those of you who've been involved in a field project, you know how important site selection is in terms of representativeness of the measurements that you're about to take. Well, imagine being able to go into Google Earth and into Street View and go somewhere based upon some inquiry-based assignment that you may have inside this module, that you're supposed to set up a wind turbine, a wind farm somewhere, and you have to do some measurements. Imagine being able to go in there using Google Earth and Street View and be able to determine whether or not, and you're going to have measurements, you're going to have the wind measurements, temperature measurements, humidity measurements, whatever, coming into a particular area, and be able to determine whether that's a good site or not. And if it's not, why not? And where you have to go and what you have to do to make it good. In addition to that, imagine, you know, I'm sure many of you who teach instruments courses, you do the same thing. You'll put an instrument out on a table, you'll take the instrument off, and okay, here's the reaction chamber, and here's this, and here's that, or whatever it is, you know. But imagine being able to do that, and then all of a sudden transform that into sort of a cartoonish kind of interactive activity where you can go in and you can modify things, you can look inside things, move them around. That's what we envision for these modules. If anybody has ever played with the space weather module, which is my favorite of all, and gone into the deep physics section of that module where you have an equation and you bring that equation out and you want to make that equation into something that makes sense to the students, so you knock it apart and there goes the Jacobian and whatever, and all of a sudden it comes into something that, oh wow, I understand how that came about. If you don't know what I'm talking about, you owe it to yourself to go to the space weather module and look at the deep physics or whatever it's called. I forget the name of it right now. But it's really well done, and that's what we would like to do with these modules. Okay, now getting back to my PowerPoint here. We have, as part of the Millersville contribution, we have an educational expert involved who is going to be doing some assessment, you know, pre-post online testing for students enrolled in these pilot courses. And like Allison said, we're going to try to make these available in the summer prior to a fall semester where you might be teaching an instruments course. We'll have those available to you, 3 per year. We have online surveys for students. We have these web-based user logs. And I was involved with Dr. Mackin a few years ago in a project with MIT called Weather in a Tank. And that project, we used web-based user logs as well, and it was really, really informative to see what the educators felt about it, you know. And it's not just all about the students, it's how we feel about it and how it's working as a supplement in our classes. And then a web-based survey for the educators as well. And then we have these questions related to the evaluation objectives. You know, what's the impact on the graduate and undergraduate learning? Can we assess that? We think we can. Does it meet the targeted needs that we specified in the proposal? Are we accomplishing what we hope to? Can we meet the needs of a wider audience, maybe even wider than the atmospheric and related sciences? You know, I mean, you can go beyond that, but we hope you will all become friendly users. Emphasis on friendly. And then, and then the question is, how do you sustain this? Well, Comet has already a process for sustaining their modules. We would want to make sure, though, that, one of the main reasons why we're doing, the impetus behind this is that instruments are always changing. Technology is changing. Maybe some of the fundamental basic electronics and things like that do not. But, but we want to keep this contemporary. And so we want to make sure that it's sustainable. And as long as the changes are minor, I would say, it's fairly sustainable. Major changes may have to require, going into it and a fairly major fix, and or not a fix, but some new technology comes on board that really needs an additional module or additional section, may require something. But most of this is going to be tweaking if there's changes. A new instrument comes on board, a new methodology comes on board, something like that. And now I'll turn it back over to Allison for the last couple slides.
Great. Okay. So Rich has touched on extending the activities and keeping them sustained. So we're going to do a soft release to a group of faculty and students for a structured review of these modules, and that's when we'll be able to get more feedback and make some changes before there's the final publication of it. Again, we're going to be doing a short course offered at AGU and AMS, and updating the content and keeping them relevant is relatively easy within Comet, where it's within the UCAR family, so we'll be able to stay in touch with them and have a nice established relationship with them. So it's much easier to get in touch with them and say, hey, we need to make an update and get it done in a good time frame. So we do have those practices in place in order to keep them updated and fresh. And that's it. Although I did want to just mention that this picture here was a picture from the NCAS Instrumentation Summer School that's offered over in Scotland each summer, or each, I guess, late spring. And I had the fortunate opportunity to go over there this past spring and observe what they were doing over there. It's really designed for first and second year PhD students, and they're getting great hands-on training, and it's a 10-day course for them. And so I went for the latter half of the program, and we're hoping to collaborate with NCAS as well for in the group of people who teach the atmospheric measurement summer school training course. So we're going to be able to work collaboratively with them and provide something that they can also use as well. So that's it, and I'd like to open it up for any questions.
I think that's a wonderful idea. We would like to use that at UBC for our instruments course. I have a request. For each instrument, can you also include a data set of the actual output measurements from that particular instrument, an unclean data set with all of the spurious, bad data that needs to be cleaned up, so that students can have an exercise where they use the data, they clean it up, they plot it. If the instrument has output that's in a more obscure format, where you have to use special software provided by the vendor, it'd be really nice if you could get the license so that we all could use that special software in the exercises too, to give the students a real-life experience. And hopefully have more than one data set for each instrument, so we have one learning exercise and then one testing exercise with different data.
Right, great, thank you.
That's exactly part of our conversation, Roland. Yeah, you bet, it'll be there. Thank you for that.
Yeah, so this is wonderful. I like it, and I was thinking as you were making your presentations of how it fits into my annual meeting theme, which I don't know if Allison's familiar with it, but Rich is. And I was just wondering if a talk on this is going to be presented at the education conference at the annual meeting, because I wanted a session there on, since observations lead the way as the theme, I wanted a session there on the education of students in measurements and instrumentation and how to make observations properly. And that will actually be captured as well and put into this BAMS article I mentioned yesterday. So I was just wondering if anyone's talking about that.
We have an abstract submitted to the Symposium on Meteorological Observations, not on the education.
Oh, okay, well, then that'll be...
Special Symposium on Meteorological Observations.
Okay, then that'll be captured as well.
Yep.
Yeah. Great.
Yep. And we have a poster also at AGU during the education poster session.
We're trying to get it out there and, get involved. And for those, I see, Vonda, Brigida, Amanda, others that have been, influential in making this happen. We very, very much appreciate this. I've done it without the, village.
Any other questions for our speakers? Great, let's take them one more time. All right, we are a bit ahead of schedule, so I was going to open it up here for any more questions or comments, challenges, opportunities that your universities are facing regarding technology. We do still have Mohan here and some other folks that may be great resources to ask and collaborate on some questions if those are things that you would desire. All right, then we're going to take about 5 minutes here and give you a little homework from the Board on Higher Education. Every 2 years we organize this, and often when we get together for the first organizing meeting, we go, well, what should we do? What should we do for this meeting? What should we do that's the same? What should we do that's different? So there should be a few pieces of paper left over from some previous sessions. If you could take that and write down anonymously a few things that you thought went well with the heads and chairs meeting, things you'd like to see happen again, whether it's particular sessions or discussions, format, anything like that. More importantly, things that you would like to see improved about the heads and chairs meeting. Any suggestions you have for topics for future heads and chairs meeting, or ways in which we can sustain your collaboration in between the 2 years when these occur. Anything like that would be fabulous. And if you wouldn't mind, we can go ahead and just on one of these front tables kind of collect those when you've finished those. So feel free to discuss with the people at your table some of these things as well to kind of flesh out any thoughts you have. But again, we just want to be able to collect some of this information so we can utilize it in future heads and chairs meetings.
Stuff, especially that last slide, and what we need to teach the students. We're going to get that stuff in there and everything. These slides are going to be posted and everything, right? Yeah. So, anyway. Good seeing you.
All right, so some of you may still be writing and collaborating or collating some of your thoughts, but we're going to go ahead and move on to the last part of our agenda for this Heads and Chairs meeting. And the last segment here is an open discussion with the UCAR president, Tony Busalaki, and he'll go ahead and take the stage and lead it on down. And again, whenever you get a chance, just feel free to bring your comments forward, whether now or at the end of the meeting, and I'll be gladly collect them. Tony.
Thanks very much. So I just wanted to follow up on the invitation I gave you yesterday and take advantage of your presence here, especially those that were not at our members at the members meeting, but to hear from you in terms of what the organization, UCAR and NCAR, can be doing to better serve your needs in the university community. So this morning from Mohan, we heard about Unidata, big data and access to big data, some comments about Cosmic. I think the NextRad example is very illustrative of being on the cutting edge. So we're not dealing with teletypes anymore, but how do we improve access, ease of access to data, as just an example. So I don't want to get hung up necessarily on that, but that example where the partnership between NOAA as a government entity, the private sector in Amazon, and UCAR bringing those entities together and then supporting the needs of the university community and providing better and easier access to the NextRad data, where since it's been in the cloud, access has increased by a factor of about 2.5 times in terms of what it was before. We heard about the Data Management Resource Center on Unidata, and in Rich's presentation just now we heard about Comet and EOL. One thing that hasn't come up are likely to be the increasing demands on us with respect to IT security. So yesterday at the board meeting, we invited Louis Uccellini, the head of the Weather Service, to speak to us. And he was pretty clear that if your platforms are not certified with respect to being free and clear in an IT security sense, NOAA will shut down your access. And so at Cosmic, the program has gone through the FISMA security process. And as universities go forward with data processing activities where they're serving a team, or let's say if it's a scientific technology center going forward, or any entity where they're serving data of which the government's going to be involved in it, more likely than not, that activity is going to have to go through FISMA security clearance. So those are just some of the activities that came up today, but I really want to, again, take advantage of your presence here to have at me of how we can better serve your needs going forward. Fred.
All right, well,
thank you.
They may be interested in this. As you know, NCAR supports a lot of community models. So there's CESM, there's WRF, there's MPAS, now there's FV3, which I think NCAR has pledged to support. But the models of support are different in each one, the governance structure and so on. I was just wondering if you could sort of outline the modes of the different ways in which these different community models are going to be supported and made available to the university community.
So we could spend a lot of time on this one. Now let me just say that I think if you look across the country, this is the organization that has the most experience on community models, in particular WRF and CESM. And so in the particular case of where NGGPS, how NOAA's effort in a national effort goes forward, we stand ready to assist where we mean NCAR and UCAR. There are, as you well know, there are workshops coming up in the month ahead regarding how to scope out what it means to do a national modeling effort. And I think illustrative of that willingness to be an interface with the community UCAR, let's say as an interface between NCAR and the university community in terms of community model development, is the fact that we're now hosting the leadership of the Joint Center for Satellite Data Assimilation. And so I see that as a good example where NCAR, in terms of Jeff Anderson, those people that were at the members meeting, has a very new, vibrant activity in data assimilation. We've had external advice encouraging us to collaborate, coordinate between NCAR's data assimilation efforts and the Joint Center. When I was on the Board of Trustees, that was exactly what I was advising, that our data assimilation activity in NCAR has to be coordinated with the data assimilation activities at other national labs and other universities. So from an NCAR perspective, what is the unique role that NCAR provides in data assimilation? And the Joint Center provides an opportunity to provide that interface to the larger community. To answer your question, I see the same possibility arising with respect to model development in terms of a national model development. Now, this is why I invited Louis Uccellini to the board meeting. That's going to take resources. All right, that's going to take NOAA to step up and provide the resources for a community modeling effort, and that's kind of new for them to do it. It's new for GFDL, who is the host institution for FV3, to have openness and collaboration. But we stand ready as UCAR to serve as that interface, much like we saw from Unidata, et cetera, and Comet, as an interface between NCAR, the university community, and the other government labs. And so, you know, the meetings over the next couple of weeks are very important in that regard. And I'd say another area where that's ripe for such university collaboration is the water area. Water quantity, water availability, water quality. NOAA's new National Water Center in Tuscaloosa, Alabama, for which the non-civil servant staffing is UCAR. The Wharf Hydro model came up and out of NCAR, started with NSF investment, then was leveraged with private sector and NOAA funds, and is now the national water model. I think that's going to usher in a whole new era in operational water forecasting, broadcast hydrology. So just like we see broadcast meteorology, we're going to be able to turn on the television and see, you know, visualizations at the street level of forecasts for flooding events, unfortunately, like we've seen with Matthew. So again, that's another area where I believe UCAR, working with the community, can really help to accelerate this new era in water monitoring and forecasting. Rich.
Tony, are you able to comment on yesterday's signing of the executive order on space weather? Can you bring us up to date on that?
So, I mean, I'm not all that familiar with it. I mean, we have been playing a role in advocacy. So we were thrilled. I mean, we had heard rumors it was happening. You know, I don't know the nitty-gritty of it because there's also still talk in Congress of a space weather bill. I'll say Boulder, in some sense, has an opportunity to really lead the way. Boulder, not just NCAR, UCAR, but it's Boulder, CU, SWAPC. This is the heart of space weather in this country, and we're not as coordinated as we could be. And so the executive order provides us an opportunity in that regard because there are provisions in that order to get the data out to the larger community as fast as possible, as well as the private sector here in Boulder. That's one. Within the past year, UCAR held one of its briefings, the penultimate one this year, was on space weather. And so for those that were at the members meeting, one of the participants at that space weather briefing was Thomas Zurbriggen, who's now the head of the science division at NASA headquarters. So we're pleased to see that. And a lot of collaboration between Senator Gardner in this state and Senator Peters of Michigan. Senator Peters opened our space weather briefing. I was really impressed. He spoke for close to 10 minutes extemporaneously, no notes at all, on the topic of space weather. I mean, he was very well informed. So I think where we go together as a community, so I'm going beyond just the Executive Act, I think that's illustrative of the fact that where we go as a research community and the operational entities in the government I'm very upbeat on that, because space weather has always fallen through the gaps organizationally between the government, at the academies in studies, and I think we're going to see a lot more emphasis on that in the year to come.
I just wanted to add, I'll put on a UCAR hat for a moment, that it does seem like a real opportunity for HAO. And, I mean, with regard to bringing these three entities together, SWPC, the CU, Solar Observatory.
I was not trying to be parochial, all right, but since you set me up, so Scott McIntosh and I, Scott McIntosh, the head of HAO, have had a lot of discussions about that, and Scotty has some really nice ideas. I don't know, there's a Academy report out on CubeSats that Thomas Zurbriggen chaired, and there's examples in that report about the potential for CubeSats for monitoring, essentially between Earth and the Sun. And so I think we're in Boulder, again, with the university community, we're very ripe to put forward an initiative on space weather monitoring and prediction, founded on data assimilation and predictability. And so, again, that's joint between NSO, HAO, SWPC, LASP, and the larger university community. So thanks again for the leading part of the question. Yep, so that's actively under discussion.
Okay, so I have one follow-up then.
Sure.
And that is SUMINET. Anybody involved in here at SUMINET? You have the SUMINET station. Is it in limbo right now? Yeah. So we're waiting for SUMINET to take the next step. Do you know anything about?
So I can't speak and tell you about it. I'm actually happy.
The space
No.
that we get the total ionospheric electron content out of that.
Yeah, so, you know, that's part of the mix of observations, but I can't speak more about that, sorry. Other areas, topics, we can better serve your needs. And one of the concerns, and I believe it's legitimate, is, I mean, I suspect you're kind of in the cognoscenti, but any suggestions or recommendations about how we could better inform you, educate you with respect to the access to our facilities. In particular, the high-performance computing platforms, and as we just heard, the aircraft observations and the instruments and the instrument activities of EOL.
Just to break the silence, so I just noticed that the radar NextRad data is whitelisted for EDU addresses, but evident probably not for .ca. So what's the, I mean, we are parasites and free riders and all this, but we'd really appreciate access.
I will inform Mohan. And on that topic, I think we're going to see an expansion of Canadian universities in the UCAR consortium. So there's some discussions ongoing right now. Canada itself is looking to form a UCAR equivalent, but and then have greater exchanges between more Canadian universities and the consortium. So we see more of that in the year to come. And I very much welcome that. So, well, please, great.
What can we do to help UCAR win the renewal of NCAR?
So we have Packer within UCAR that's advising me, and the one thing I've charged Packer with is we have a number of outreach activities. You visit, you match, you connect. And what I'm going to be charging Packer with, so thanks again for the question, but Packer with is evaluating those outreach and exchange activities, because we can always be doing more. And so we'll be providing a survey. So when that comes out to the member institutions, I ask that you pay attention to that. And the other thing I would say is, if you have, and Packer was collecting this, if you have illustrative examples of how your university has benefited from the relationship, please send me those examples. I think we know a good range of them, but even if they're anecdotes or more of substance, please pass them along to me. So I appreciate that. Please pay attention to the U's. But again, just contact me, Tony B. at UCAR, in terms of your ideas, or go back to your home institutions in your departmental meetings. I mean, one of my concerns is, I think across the country, the level of engagement between the member rep and the department itself is varied. And so in that regard, I would like to ask that you go back to your departments and have this discussion, these questions I'm asking of you, and as a department, do some thinking about how UCAR can better serve your needs going forward. That would be extremely valuable to us. Thanks for the question.
On the recompete, is this going to happen every 5 years from now on, or?
Oh, so already every 10 years, a full up, open competition with a renewal proposal 5 years after that. But so that, it's nothing new at all. And again, we look forward to this. We have areas to improve on, and this is a great opportunity, especially me being the new kid on the block, to make improvements. So I'm really looking forward to this. All right. So again, thank you for your time. And yeah, and please go back to your department. Oh, one more, sure.
I'd like to ask a UCAR members meeting question. Tony Hansen, St. Cloud State University. I've been the member rep for my university for 14 years, I think. When I was first a member, I was one of the Untermensch, the academic affiliates group. We became real people a couple of years ago. But we used to have a meeting on the Tuesday morning of the members meeting of the affiliates only. And at that meeting, we discussed issues related to undergraduate education. I think there's several people from these universities right over here. I think it was probably the best part of the members meeting. And Rich has told stories in the past about going into the main members meeting and having the members saying, why don't we discuss interesting things like those guys discuss? And I wonder if we couldn't bring back something like that at a future meeting.
I hear you, but what I'm going to give you homework, please contact Packer, right? Because Packer, it's the members meeting is their meeting, and they set the agenda. So yes, I can go back to Dan Sizzo now, who's going to be the new head of Packer, but I think it's more value if you contact Dan or Yvette. One of the things we just talked about the other day was what should be on the agenda for next year's Packer meeting. And I think we talked about a range of possibilities, and I think they're going to go out to the membership with kind of a list of, would you like to see these sorts of items discussed? So please contact Yvette and or Dan as they start thinking about what's going on for next year. Yeah, great. So thanks very much. Yep.
All right, any other final comments for this edition of the Heads and Chairs meeting? Anything for the good of the order, if, as they say.
Thanks to the organizers. Yes. Thank you.
All right, if there is nothing else, that will officially conclude this year's Heads and Chairs meeting. I do ask, though, that you've written your feedback, and I would love to collect that feedback. So we'll go ahead, and on this first table up here, we will start a pile, and I will collect this and collate it and type it up so that I can get it to the AMS Board and Higher Education to serve as a starting basis for the next Heads and Chairs meeting in 2018. Thank you all very much. Safe travels back to your home institutions.